All right, so let's get started. This is where I want you to have pulled up that document that was in course documents for 2.1 to 2.3. Here's where we want to get a really good start to solving these equations. And so I really want you to kind of understand what we're trying to do and have a good way of thinking about it, okay? All right, so let me just kind of jot it down up here. So like with this, we're not trying to get into things too crazy. We just want to be sure we can solve something like 2x plus 5 equals negative 13, something like that, okay? And so this is called a linear equation in one variable. It's an equation because we now have an equal sign. We did not have that in the previous chapter, okay? We just had expressions. And so like 2x plus 5 by itself is an expression that can take on a lot of different values. And our job is to figure out what the x right there needs to be in order for the value of 2x plus 5 to turn out to be negative 13. Now, some of you have really good number sense, and that's great. But I don't want you just guessing and checking your way to the result here. The whole point is to learn a process that allows you to very quickly and efficiently work through problems of this type, okay? Now, here's what I want you thinking about in the back of your mind on these. I want you thinking about the equation, the equal sign, kind of like as that, or think about a piece of playground equipment. You know, the equipment on a playground that looks like this and kids sit on each side of it. We used to call it a teeter-totter, and then I think sometimes people call it a seesaw. But you know how people sit on either side and it goes up and down? So if you're the heavier kid, if you're sitting at the same distance away, but you're the heavier kid, and you lift your feet up, it's going to drop to the ground, okay? Well, I want you to think about the equal sign as meaning that these two things, they're located exactly the same spot away from the fulcrum here, the center point. This is where the equal sign is, okay? And the seesaw is perfectly balanced. And so that model, that image is what I want you thinking about in your head as we talk about how to solve this, okay? This type of equation. All right, so first off, our goal is going to be to take an equation like that, and at the very end, we want to know, x equals what, okay? So the goal is to get your variable. Let me do this in red here. And you could be completing the handout if you were able to print it. The variable equals some number, okay? That's your goal. Right? So when they ask you to solve something like that, that's what they want you to get. X equals what number, okay? All right, so here's what the process is going to be. You're going to first work on, sometimes it's way more complicated than that. So you're first going to simplify each side separately of the equation. So take the expression on the left and get it as simple as possible. Take the expression on the right and do the same. Okay, like take a look down here where you see the one that's got like 4 times parentheses 3r minus 2 minus parentheses 11r minus 4. Get that simplified, okay? Okay. All right, then what you want to do is you want to work on getting the variable terms on, I wanted to say variable terms there. The variable terms on one side of the equation and the numbers, constant terms, on the other. Okay, then what you want to do is get the variable by itself on one side. Okay. And then the step 4 is really, you're done solving after number 3. And then what's nice in this unit, we didn't have the luxury in the last one of doing this very often, is you can check your answer usually pretty easily, okay? Now, there's so much variability in how these equations are going to look that you will not survive if you try to just memorize how to do this. And, if a problem looks like this, this is what I do. Instead, you need to keep in mind the following guidelines. Okay. The first one says you need to undo whatever has been done to the variable. Okay, what I mean by that is on that example, 2x plus 5 equals negative 13. Here's your variable. You see how x has been multiplied by 2 and then you've added 5? You're going to need to undo the adding of 5 and you're going to need to undo the multiplying by 2. Okay, so that's the one key idea, is the idea of using inverses, using inverse operations to undo what's been done to x. Okay. Then the other major guideline is that whatever you do to one side of the equation, you must do to the other. Okay, so whatever you do to one side, you must do it to the other side of the equation. All right, and that has to do with the fact that we need to be able to keep this thing balanced. Okay, so this is right now, everything's nice and balanced. So for instance, if I decide to subtract 5, and so that's going to leave me just a 2x over here on the left, well, I can't just leave this a negative 13 over here. It won't be balanced. If I subtracted negative 5, let me say that better. If I added a negative 5 to the left, then I need to do the same thing to the other side of this equal sign in order to keep it balanced. Okay, so I won't have a negative 13. I'll have a negative 18 really. Okay, so this right here is really what I want you thinking about more than anything, is that the idea of solving equations really has to do with undoing whatever has been done to the variable. And then this other concept that if you do something to one side of the equal sign, you have to do the same thing to the other. Okay. All right, so let's go ahead and try a few of these. All right. So what's happening here is these first two rows at the top, hopefully it's going to let me write in there okay. Those actually come from 2-1. 2-1 deals with problems where something has been added or subtracted to the variable. Okay, so for instance, on this first one, my goal is to get the n by itself. So I got to undo this subtracting of 12. So adding and subtracting are inverse operations. So to undo the subtracting of 12, I want to add 12. Now, if I've done that to one side of the equation, then the guideline says I need to do the same thing to the other. And we added 12 because that's going to make the negative 12 go away, and it'll leave us the n on a side by itself. And then be real careful about your positives and negatives. A negative 3 and a positive 12 will be 9. Okay, so your answer is 9. Okay, and you can check these by just plugging in. What you're saying is, if I plug 9 into the variable right there, 9 minus 12, that's going to give me a negative 3. Okay. All right. All right, so let's try the next one. So the one next to it is just like it, except for the b is the variable is on the right-hand side. That sometimes throws people. Okay, it's perfectly okay to leave the equation the way it is and just think that your goal is to get the variable by itself and to subtract 12 this time. Since you've added, you have plus 12, minus 12 would undo it. Whatever you do to one side, you do to the other. Well, that's going to give you a negative 27 equaling b. Okay, so that's your answer. All right, now some people find it easier to do this first. You know, if two things are equal, you can just interchange the two sides of the equation. They're still going to be equal if you flip the two sides of the equations around. Okay, then you can come in and subtract 12. You're still, let me write this whole thing neater. Okay, so what I'm saying is, if you really are finding that you do better when the variable is on the left, which most people do. Just take a moment at the beginning to rearrange the equation. Then you can come in and subtract 12 from both sides, and you wind up with b equaling negative 27, and it's sometimes conceptually just easier to see, okay? All right, this next problem is also section 2.1. Don't let the fractions mess you up. Your goal is to get the x by itself. You've got to undo the adding of 1/4. So you can subtract 1/4 or add a negative 1/4 to both sides, and that should do it. 1/4 minus 1/4 is gone. I get the x like I want. And then right here, you can just use your calculator to do this. You don't have to be able to do this by hand. So you really are just going to type in negative 4/5 plus negative 1/4 or negative 4/5 minus 1/4. Okay, I'm going to go ahead and do it by hand. So if I did it by hand, I'd have to get a common denominator. And I'd have a negative 16 over 20, and then a negative 5 over 20. So I'm going to wind up with, you should wind up with negative 21 over 20. And that can't be simplified. So that would be the way they would typically want it, is a fraction that's been fully reduced. Okay. All right, now with the next one, we've just got some parentheses and things. So like this right here is just like what you've been dealing with in section 1.7. So let's just get it simplified first. So we're going to distribute. And then this is the kind with a negative, no apparent number. So slip in an understood 1 right there, and then distribute the negative 1 to both. So you'd get 12r, 4 times negative 2 is negative 8. Negative 1 times 11r is negative 11r. Negative 1 times negative 4 is plus 4. Okay? All right, now what I'm noticing is I have like terms. 12r, negative 11r, that would be 1r. So that's just r. And then negative 8, positive 4. Don't put 3 with it. We're just working on simplifying each side right now. The negative 8 and the positive 4 are like terms, and I'm going to get negative 4. So that's where I'm at right now. So see how I converted that complicated equation into one that looks really just like this guy did. Okay, so I need to get rid of the minus 4, so I'm going to add 4 to both sides. And when I do, let me erase that squiggly line. And when I do, I wind up with just the r, and it equals 7. So 7 is that number that would make this a true statement. Okay, so that covers what happens in section 2.1 problems. And they're ones where you have something either added or subtracted to the variable. And so you use the addition property of equality in order to take care of those. Okay. All right, in the next video, I'm going to be looking at these problems. Let me see, it goes all the way to here. All right, these problems are section 2.2, where you have a number being multiplied or divided. Okay, I like to keep my videos short because I find that it's easier for you to be able to play them and watch them.